every project at some point, like, kind of hits the fan and you have to figure it out. It's just kind of the nature of it when you're dealing. I mean, it's software, hardware, whatever, right?
Yeah.
The famous saying, when you the battle plan changes the moment you meet the enemy, right? So,
I'm Erin McDermott, your host with the Odd Engineer podcast, and this is episode number 6. We have Kyle Visner, who, if you've been on oddengineer.com, you would have seen him as our IoT guy. He's the one and only IoT guy. And Odd Engineer, the pilot, has closed for now, but for a very limited time. I think you have to book by July 14th for it to be working. You might be able to book an appointment still with Kyle. But anyways, thank you, Kyle, for coming on. Appreciate you being here.
thank you for having me.
And I'm super excited about this one for 2 reasons. Because for number 1, I know nothing about IoT. Like, I understand the hardware side, I understand about manufacturing and the widget side and the physical components, but then it's like, and then there's IoT and we just hand that off to Kyle. so I'm super excited to learn from you. And then number 2 is you're my home dog. Like, you went to school at RIT, so even though you only lived there for a limited time, you're my neighbor. That's Rochester, New York is my hometown. So good to have you on.
Well,
so you want to just tell me, maybe going back to like how you ended up getting into this career path?
Sure. So, as you mentioned, I went to Rochester Institute of Technology, and I have a degree in computer science from there. While I was there, one of my areas of expertise was robotics. So I actually spent a period of time while in college working with a DARPA contracting firm in Pittsburgh called RE². And well, after I graduated, I sort of decided I didn't really want to go down that path at the time, and I went kind of into more like general software development.
Mm-hmm.
So I worked at Amazon for a bit and a couple other companies doing everything from like some SDET type stuff to full stack software engineering and web technologies. And then after when I decided to sort of get back into running my own business, I wanted to kind of take those 2 areas of expertise and bring them together. And the obvious point to do that would be in the modern incarnation is IoT. So yeah.
Nice.
Mm-hmm.
So wait, but was it really like you just went right from one to the other? Are you skipping some steps in there?
What do you mean?
I guess not. So like, how long after you graduated from college did you start your own business?
So I graduated in spring of 2013. And I then went to work at a company in Charleston, South Carolina called Blackbaud. And then from there I went to work at Amazon. And so I left Amazon in the fall of 2015 to start my own company. At the time I was just doing general web and mobile app development, both developed my own apps and working as a consultant a bit. I did that for about a year and a half, and then I went to, in January 2017, I went to work at another company in Soto called Visible that is now part of Adobe. But after I left there, when I decided to go ahead and go back into running my own business, I knew I didn't want to do general purpose consulting anymore. I wanted to really kind of get into more specialized fields. So around probably somewhere mid 2018 is probably, you could say, is when I started doing more IoT focused work.
And now you're swamped, which is good. That's really good. So, okay. So then tell me about, you have one foot in the robotic side, you have one foot in the web development side, and you brought them together with IoT. Like, tell us some more details about what's involved in those areas. Maybe with
Well,
example projects if that's easier.
well, robotics is kind of self-explanatory. I worked on robots that literally had, arms and kind of moved around and grabbed stuff.
But are you actually putting them together, or are you just working on like the coding side?
I work on the coding side. So yeah, I'm not mechanical nor an electrical engineer of any kind. I'm okay with CAD actually, but that's more for like 3D printing rather than like anything I normally bill for.
Don't put yourself down
Yeah.
for that. That's a good skill to have in your back pocket.
Yeah, I mean, it comes in handy from time to time, but I don't have the
Yeah.
pedigree of like a true mechanical engineer. But uh, so I normally focus more on the software side. So when we're talking about hardware, this would be embedded systems, which historically would be embedded C or C++. Over the past 5 years or so, that's kind of started to shift as there's been kind of a push to move some other languages in that are better for developer productivity. So you're seeing Python and even Go and some of these other languages are getting like versions of them created that can run on embedded systems. And that's also been helped with the rise of things like the Raspberry Pi and some of these other like really small, low power computers. I have a couple clients where, we've more, it is an embedded device, but the thing embedded in the device is a real computer, not like not just a micro controller with some embedded C on it. And so that's kind of a embedded side. And then the flip side would be, in most embedded systems now, we want to get data off the device and get it into some other space. So that could be as simple as just like, we Bluetooth into your phone and then we maybe just keep it there, do stuff there, or we Bluetooth your phone, it's put up in the cloud, or we have an actual Wi-Fi or LoRa modem on the device, and that then can go into the kind of connect via the internet, go to AWS, Azure, your own servers. And then from there, once you're in there, kind of the sky's the limit on what you can do with it. Because at that point you have, the power of the entire internet if you want it.
So are you actually making mobile apps too?
I do some mobile app work. I'm not the world's greatest UI engineer or designer. I tend to focus a bit more on on the communication layers and the interfaces to either the hardware or to the cloud. If people want really flashy UI stuff, I typically will bring in someone else or tell them they should probably bring in someone with a bit more expertise there. But yes, I do a decent amount of mobile app stuff.
Cool. So you just mentioned Raspberry Pi, and this is like a sore point in manufacturing. And I want to hear like your thoughts on it. So from where I sit, like if someone is using a Raspberry Pi module, so they built some other components on top of that, and maybe it's like a camera, well then you're using libraries to turn those photons that hit the sensor into something else, and it's like a black box. You don't know what's happening in there. So if you're gonna take that prototype and scale it up into manufacturing, that's so much mystery in what's going on in the code that it's like, if you're using like an optical device, that's a really, 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 really bad idea. And you never, ever, ever want to do that. But maybe outside of that, are there applications where it makes sense to retain your Raspberry Pi module when you're scaling up into larger volumes?
Yeah, so first of all, I would never really recommend that you scale up and you put entire Raspberry Pis in your device. That's aside from the economics of it, like there's a lot of things there. But for example,
okay, good. So that's across the board. That's good to know.
The Raspberry Pi does come as a compute module. So this is just the computing core of the device, not like the Pi as you think it. And that is designed actually for custom use cases. So you would create your own carrier board for the module with your own peripherals on it. And then now the caveat with Raspberry Pi that you kind of got into there is that you're not necessarily guaranteed real-time operation because it's a general purpose operating system, right? So there's other processes running that might be taking compute time, and you don't. You might not. If you think you're flipping a sensor on at millisecond X, but it may or may not happen at that exact moment because there's your time sharing on the processor with Wi-Fi or whatever other operations have to happen. That being said, you can architect around that when you do when you choose your components for your hardware. So, for example, let's say you're looking at something called an ADC, which is it's a analog to digital converter. Raspberry Pi does not have one on board because it's a real-time operation. But it's very common to interface it with a protocol and has a buffer in it. So you can go and you don't need to be absolute real-time. You kind of have an integrated circuit that buffers some readings up, and simultaneously you are like, I would like a reading, I would like a reading, I would like a reading, and they kind of come in. So you cannot use, and I would move beyond just Raspberry Pi, and I would say, because there are a lot of what are called SBCs out there, and even back in 2013 when I was doing robotics, they were running on SBCs. They were not running on microprocessors because we wanted to run complex vision algorithms, and you can't run that on a microprocessor. Or sorry, on a microcontroller. You need a hard drive, and so it comes into, and then they get into, it comes, when I do it, I work closely with the electrical engineer, and we all right, you have to sort of put the real-time operations in one bucket and everything else in another bucket and figure out how you're going to architect the system to deal with it, right? So for example, with your optics, if if you're trying to do, sub-millisecond type operations like that, and with really aggressive context switching, you might use a co-processor that handles that part of it and then communicates back to your general purpose computing core to do machine learning or anything else you want to do with it, potentially.
Beyond timing, though, there was also an issue with just how the image is being processed on the image processing side, because there's lots of averaging that's going on between pixels and stuff like that, and every sensor does it differently, and you don't know what's going on. You can dig into the library and it doesn't tell you to that level of detail. So there's this camera guy, Alex Fink, who his specialty is image processing, the firmware for the image sensors, and he's never Raspberry Pi modules, never, always custom firmware, because you don't know what's going on. So then when you try to take that image and then maybe read a code or something, you can't optimize that because there are missing pieces. When I build an optical simulation, you need to know every single piece so that you can see where the weakest link is. And then if it's just all right, lens, distance, illumination, black box, and then you learn nothing. So that's interesting hearing it from your end of things.
Yeah, and it's actually not a black box. You can always write your own library. It just takes a lot of work. No.
Yeah, but then in that case, why don't you just use your own sensor and build it up from scratch anyways, right?
Yeah, no, you're not wrong.
So it sounds like on the software side of IoT, just with physical product development, the physical side, you're always going to be optimizing way, way better if you do stuff from scratch. There's going to be saving processing time and probably power and doing things more efficiently. And
yes, and then but the flip side is that gets very expensive.
Right. Same thing with physical product development.
Yep, very true. So when I work with clients, that's a common something you always have to weigh is it's like, where to spend the money, right?
Yeah.
And, if we don't need real-time operation, we don't need super low power, we can take one path. If we do, we take a different path. But one of the things that always, it's kind of one of the realities of when you do hardware projects is that when you make decisions, you do preclude yourself from doing certain other things.
Yeah.
It's a bit different than pure software projects. So if you choose, so for example, if you choose to go with a micro, so we'll start with the SBC side. If you choose to go with a single board computer, you are pretty much precluding yourself from very low power operations.
Mm-hmm.
Now, I say very, the Apple Watch is a single board computer. A lot of health wearables are as well. So you can be pretty low power, but if you're talking like, I want to build a sensor node that I'm going to run off a small solar panel for the next year and a half in a field, okay, that's going to get kind of hard. So that's kind of one side of it. And you do give up true real-time operations. Usually, there are some products out there that use co-processors and things. You can kind of move real-time operations over there and kind of do that. The flip side of that is if you choose the microcontroller route, and this is something that's come up on some various products I've been on, is if your requirements change, you might need to start redesigning your entire system, which is bad and really painful and tends to make people unhappy. So it's always a balancing act, right? You need to choose where, like, look at your business, where are your business risks, and then chart a path forward. So if you have the luxury of putting a car battery in the thing, which I have some projects where we do have that luxury because we're automating large objects and we can have a big battery, then you might want to choose something that gives you more flexibility and agility down the road versus I have other projects where we're dealing with very low power wearables for like sports or medical devices, right?
Mm-hmm.
And then you would choose a very different path. You're going to go with try to really go with the smallest computing unit you can get away with the smallest battery, and figure out, get really in depth in your battery calculations. But if down the road you're like, I want to run a machine learning algorithm there, well, you can't. So that's just an option that is no longer open to you. So there's a lot of design that goes into when you're coming up with solutions like that.
And since you have your own business, I imagine, but let me know if I'm wrong, that you would have a pretty good perspective in being able to guide people to think about, if you go this path, think about this a few years down the line, where is this going to go? Do you help them on that side too? Or is it just like when there's a glaring error?
I mean, I generally, it depends, because I'm not the one who's going to do the customer development for them. Like that's, one would assume if you're starting a business, or if you have an existing business and you're making a new product, that before you're going to engage with service providers, you at least have some kind of information about what you think the market is asking for or needs, right? And it's not really my place to tell you that. And also, like, typically I'm not the expertise in your business nor your marketplace, right? So not that way, but I do a lot of I do often act as a solutions architect as much as a firmware and software developer. So one of the things about hardware projects is your software team is going to be with you probably a lot longer than any of the other disciplines involved.
Mm-hmm.
So it's not uncommon for me to be the first one.
We just lay those other bastards off.
Well, it's more that it's that, you know, in electrical engineering, for example, right? You know, you're going to do a revision of the board. You're going to test it, debug, you know, do all that. Maybe do a couple other revisions. At some point, that kind of gets shipped, and you know, if you're at a large company, that you might just move on to the next revision. If it's a smaller company that's just trying to get like a new product launch out the door, like they might not be ready for, you know, V2 to start paying for that yet, right? So
Yeah.
When you're in those disciplines, it tends to kind of come in and out. Whereas you know, when you're in the cloud side, software, it's kind of a living process. So, you know, you push, you get feedback, you iterate. It's very iterative. So that does also give me a unique perspective to be able to kind of act as that solutions architect, be like kind of guide from a technical standpoint, reducing how we can, you know, reduce the risks in the project, and also you know, amplify certain opportunities.
Yeah, great. So your business is at Spinnaker.Design.
That's
and
correct.
I am so outside of the loop of IoT that I was like, why the hell I sail? So I'm like, why the hell did this company about a Spinnaker? I'm like, oh, it has to do with cloud computing. Can you tell us why you named your company what you did?
Honestly, because I like to sail. That's actually
Really?
I didn't actually like.
But then also,
Yeah, company names are. I didn't want to go with anything punny or weird, so I kind of picked something else.
great answer. So tell me more about like the clients that'll come to you in general terms. Are you taking a device that already is maybe on the shelf and they want to make it connected, or is it brand new product development and you're right there from the start to bring in that connectivity right when they're building up the hardware from scratch?
All
Or
of the
all
above.
across the board?
Yeah. No, I've come in on, you know, green field, like we want to do this and we don't know how to get there kind of projects. And I've come in on other projects where there is an existing product, it's already out there that maybe doesn't have connectivity or has connectivity, but it's not working right or something. Or they want to, you know, they want to really expand the capabilities. Or I've also come in on projects where they were kind of where, you know, there was a breakdown somewhere and they have like a half finished kind of project that they're trying to
Those are the worst.
reboot and get over the finish line. So I do all of the above.
Yeah, those ones where you come in and like the development kind of crash halfway through, those for me, those are the worst because as you mentioned previously, like once you start picking things, you're precluding yourself to other options and it becomes a lot harder. Is it the same with those types of projects when you get them?
Yeah. Those are the ones where you tend to have to be the bearer of bad news a couple times.
I
You
hate
know,
that part.
some of the worst ones is where the client thinks they have something that does X and it just like doesn't really. And yeah, so that yeah, those do happen.
Wow. Are there things, you know, if you're just trying to bring up a electronic device into cloud connectivity, whatever, are there things on the physical side that would make it harder for you to do that besides, you know, you mentioned already how much space you have for a battery. That's one thing. Are there other things that maybe it makes sense to bring you in as early as possible so that, you know, you're not physically boxed off?
Oh yeah. So for example, let's say you wanted to build a Wi-Fi enabled product. Okay. There are many many options and ways to build that, right? You could go with a a normal processor, and then you could put like a dedicated modem on it. You could go with some what are called SOMs, system on module types ones. Is that so? Let's say, for example, you want we kind of talked about it. It's like, well, we're going to build the cloud side in AWS. Well, AWS, Amazon publishes libraries for certain processors that make it very easy to connect, and they don't for other ones. So if you kind of go with one of the popular ones, they're like, we pretty much basically wrote all the hard stuff for you. We'll get a lot farther, a lot faster. If we have to build like the entire like authentication MQTT system up from the ground up, just bare metal, that's going to take a long time, and like, I mean, it's going to be, you know, probably buggy for a while because we're just kind of inventing it as we go. So yeah, I mean, like, you could get probably 6 months farther down the road in like 2 days, make the right decision there.
Wow. Yeah.
Versus, yeah, so that's a big one. Battery is always a big one because that, you know, you need power. So that form factor can sometimes come into that as well. And then there's
especially
also
with the thermal side, right? If they're not even thinking about adding on those types of components in the onset.
yeah, that can be a big one if you're dealing with especially things like high power LEDs or something that actually generates a lot of heat. Then you also have some of your auxiliary components. If I want to give you an example, if you want to have a system that has an IMU in it, like a inertial measurement unit, right? You want to measure, you know, acceleration. Some of them are used all over the place, and there are libraries for them in various platforms. You know, there are examples. There's this. Other ones are not, right? And like, especially if you're a small company, or, you know, you want to try to avoid reinventing the wheel as much as possible. That's a great way to de-risk the project, is to like only diverge from like the path everyone else is taking in the ways that are like a competitive advantage for a business, because otherwise you're just like making it everyone's day harder and spending a lot more money, right? So yeah,
that's good advice. Write that one down. That is so interesting to me that there's a lot of analogous situations that you run into on the IoT side as I run into on the optical engineering side. As a lot of companies will try to save money by getting these LEDs that they found out of some guy's trench coat in an alley in Shenzhen, and it's like, but they've never been measured, so I don't have a wave file that I can stick into a simulation, or a material that's never been measured. Like, you could have gone with one in this library, but now you save some money, but we're also going to have to spend $10,000 to ship it to get it measured. And that's 6 weeks or whatever.
Yeah, I mean, there's a saying where that's kind of an axiom, I guess, where early optimization is deadly. And that's one of them. Like, if you get really caught up on trying to get your BOM cost like as low as possible, you can inadvertently make your like non-recurring engineering costs big enough that you cannot possibly afford it. Whereas, like, okay, your BOM might be $2 more expensive, but you're in the market in 6 months, right? As opposed to never.
And then also you probably have to think about if those parts are going to be obsolete in a certain amount of time. Supply chain risks, certain parts. Yeah, I mean, if you're like, if you are building a Wi-Fi enabled device and you don't need to be incredibly aggressive about battery life, you should probably put an ESP32. Like, there's not a good reason not to.
There are other chips. There's lots of other chips.
Is that
But
just a standard part that's in a lot of things, but it soaks up a lot of power? Because like
it doesn't soak up a lot of power in the grand scheme of power, but it is a higher power. Like you could get much lower power processors, but you know, the supply chain risk is very low. The company that makes them sells, you know, a billion of them a year or something.
Okay.
And they're supported by AWS has libraries for them, Azure has libraries for them. You can write them in the language provided by the manufacturer, which is embedded in C with something that they call their developer framework, their IDF. You can write Arduino on it. You can write Python on it. You can write Go on it. You can write. So it's like it has a lot of support both from major firms and from the communities, the like open source communities. So like you should probably use that one. Now there might be reasons down the road not to use it, but maybe those reasons should be V2.
Wow, this is so interesting. Can you tell me if you have enough products that you've worked on that are actually like on a shelf somewhere? Maybe you don't, but if you do have examples of things that you've worked on, it would be cool to know like what kind of data you're shipping from, you know, the device to the cloud or whatever, or to a different device. What kinds of things have you worked on? What were the applications?
I mean, most of.
Are they all still not out?
No, I mean a lot of the data is really boring. It's like turn the device on and off from a mobile app. So it's
that's okay.
There's a lot
that, though.
There's a lot of I mean there's a lot of what I would call state communication, which is it's like the device telling the cloud this is what all my sensors are reading, so the cloud can do something with that information, or vice versa. The cloud via mobile app or a web portal or whatever, sending a command back to the device. So it's really boring. It tends to be a lot of JSON objects. Occasionally there's like photos, images. That the issue when you talk about IoT devices, and that is that takes a lot of bandwidth, so it costs a lot of money to send that over cell networks or God forbid satellite networks. So we generally try to avoid doing that unless we have a really good reason to. So yeah, no, it's a lot of like JSON text back and forth usually.
But you've worked on medical devices before, or what are some of the other industries that you've worked in?
I've done some medical stuff. I've done.
And wait, before we go on, the medical stuff, was that like stuff you needed FDA approval for, or is it just like medical related equipment?
So I've done some work on devices that were very early, so they would eventually be seeking FDA approval, but
you didn't really
like in like the trial stage.
Nice.
Like of like trying to get data about the thing you're trying to do, not necessarily that we're making the final device that's going to go to FDA approval.
Gotcha.
Sorry. But yeah, that is typically the type of like if you were like in the final stages of FDA approval and you like it gets really messy there, and it's not really like I don't know all the ins and outs of the legal stuff needed to do that. So I don't typically go that far down the road on medical stuff, but early R&D type, what I would call like an R&D mule. You know, like the thing it carries it's like it's big, it's clunky, but it carries the sensors you need, and you can kind of get them where you need them to go, kind of a thing. I've done some of those. I've done some sports wearables. I've done some
like heart rate monitoring and breath and or other stuff. Or
other stuff.
You can't tell
me. Yeah.
Okay.
Other stuff. I've done some. Sorry, talking too much. Um,
I need to get back to my nerd cave and code things.
um, I've done some smart home stuff like smart home lighting. I've done one of my clients, Throne Labs, is a smart reservable like bathroom concept that we're in GeekWire recently.
Bathroom concept?
Yeah, so
Like the whole bathroom is smart?
yeah, and self-contained.
What?
Yep. We have the one of they were just in, as I said, they were in GeekWire recently, so I can talk about them.
Cool.
So that's kind of smart homey, but also some like light industrial style automation stuff goes into that kind of thing. What else? Just other kind of like consumer electronic-y smart devices. Yeah.
Cool.
And then some specialized sensors as well. But,
cool. So you have a lot of these things. You're coming in at like the R&D stage maybe, and you're helping build out the prototype, right? You got you have a 3D printer at home?
I do.
So what kind of, tell me about like that prototype. Oh, sorry. You just cut out.
Sorry, you broke up there for a moment.
Ditto.
Yep. All right.
Yay, Zoom. So tell us about what your like prototypes look like.
I mean, so for me, they tend to be breadboards, right? Because I personally don't do the PCB design, right? So that'd be an electrical engineer who knows all of that. So early on, like let's say we're testing like a very experimental concept. So I have a project right now in where I'm developing a unique sensor, right? And in that case, you can't make a printed circuit board because you don't even know what the printed circuit board would do. So you're you're taking some dev kits and you're like wiring together with breadboards and sticking like an Arduino or something in there to just kind of drive some LEDs or whatever needs to get done. And then, you kind of, maybe you 3D print some kind of contraption around it to hold it all together and you carry it around, right? So I do some of that. So that's like very early stage. Like we're like,
proof of concept.
I would say like proof of concept, like viability testing thing. So like, yeah, is this even something that is physically something we can do? So that's like, I do some prototyping there. And I do some as part of that, I'll do some breadboarding stuff. But if we start getting really into the electrical engineering side, we need a specialist at that point. But yeah,
which is a nice way of saying that's not my job.
Yeah, it's not my job, and I don't have the expertise to do it if I wanted to.
But hey, being able to prove out a proof of concept is pretty great. And
yeah, I mean, most companies, if they have something that they are, we're talking about hardware companies, most of them have a lot of eval kits and dev boards out there that you can kind of jury rig into almost anything.
Cool.
If you need to. So, for example, for a project, I've got a 32-bit ADC, which is way too sensitive for the project, but it's way overkill. But getting someone to put that on board would take weeks and cost a bunch of money. But like Texas Instruments, which makes an eval kit for like $200. So you can buy it. You can actually, even with a USB, plug it into your laptop and start getting readings off it immediately, right? So
that's cool.
Is it ideal? No, because there's probably some noise on some of the long wires you got and all that. But that's not what you're going for at that phase.
Right.
Mm-hmm. Yep.
Very cool. All right. So if somebody in this last 3 weeks that we have on the second version of the pilot, engineer, if someone booked an appointment with you, they have a widget, They want it to get connected. They don't know the first thing about your world. What can you walk them through in an appointment?
Within like 1 hour, it would really be about a discussion of planning and options, right? We're not going to write any code in an hour.
Yeah.
So it'd be like, what's the current state of what you have? What do you want to do? And what potential options exist that can get you there? And then like what potentially, how much it might cost, what areas of expertise you might need, what risks there are. So like, I don't know the state of the art in every field, but I know that, I have a pretty good sense of if you're way out, way too far, and like you're asking for trouble. It'd be like this. So if someone came to me with their widget and they're like, it measures space magic, I'd be like, maybe we should test out the space magic part. How can we prove that out before we actually develop the space magic widget?
That's good. That's great.
Yeah. So it'd really be a discussion of like where you are, where you can go, where the risks are, where the opportunities are from the technical side of the project.
Yeah, and it sounds like you can suggest a lot of even specific things about different technologies, and like you've already mentioned right now, the choices you make between a lot of things can impact a lot of things later on down the road that you need to know up front, or else you're going to be screwed.
Yeah, that's definitely one of the harder things hardware projects opposed to software projects, is you can very easily accidentally engineer yourself into a corner.
Absolutely.
The classic picture of the guy who painted himself into the corner on his roof and now can't realize how to get off. Yeah.
I vividly see that in my mind during so many discussions. So you're over in Seattle, right?
That's correct. Yeah.
So you probably see a lot of this part too, which is software people who are like, hey, I got some money, I got a good idea, let me make a hardware project. And they are treating that development just like they would a software project. And and it comes with those problems. Are there any other like big mistakes that you see people kind of routinely making when they're going into this, especially if they haven't built a hardware device before?
I'd say there are two big areas that I've seen projects really get hung up on. So one is the one that we've just kind of already discussed, which is, in software, you can kind of get away with the like go fast and break things mentality because you can kind of always go back and fix it.
Yeah.
In hardware, you can go fast, but you do need to be a little more deliberate about the choices you're making. And so if you kind of rip through some of those choices and don't think about what their long-term repercussions are for the project, that can really cause you problems down the road. So that's one side I've seen projects get hung up on. The other big one I've honestly seen projects get hung up on is not working with the right people. And this is, again, because hardware is so multidisciplinary. A lot of people, when they start, they don't even know what they're looking for. They're like, I need an engineer. And you're like, an engineer that does what? So that it's like I've had to come to the rescue on a couple of projects where like they found someone through some meetup or website or whatever that told them they could build everything. So software, hardware, mechanical engineering, all of the intricacies of the project in one person. And then like a year and a half later, they have like a bunch of half-working stuff. And it's like, okay. But I mean, going in, a lot of people don't realize that like it really is multidisciplinary. Like you need to find and create a team, either of partners or service providers that kind of has the major technical parts of the project covered, whatever it is. So if it's an IoT project, you might need someone like me, you'll need an electrical engineer, you'll probably need a mechanical engineer, you might need an industrial designer, right? If it's, an optics project, right? A mechanical engineer probably is like, you might need one, but like not only mechanical engineer, there's other disciplines like that you're going to need, such as yourself, to kind of do that. It's if you're doing, what else have I seen? If you're doing medical type stuff, you need someone. You need a good lawyer, because someone's going to get you through
First,
that.
you need a lawyer.
Because there is a lot of paperwork, and you need someone. You need counsel that's going to knows what you can and cannot say and do.
Yes. That's why on Engineer, I wanted everyone to also talk about their industry specialties, because that is its own skill set and specialty beyond just the core, like hardcore engineering work. That's why Randall Chinnock, he developed his own R&D company for medical devices in New England, and he's an optical guy, but really his specialty is helping people understand the different steps of getting like FDA approval and all the paperwork and stuff. Like that's its own like discipline.
So those are really the two. Those are really the two things I've seen really sync a project. Most other things you can kind of get through. I mean, every project at some point like kind of hits the fan and you have to figure it out. It's just kind of the nature of it when you're dealing. I mean, it's software, hardware, whatever, right?
Yeah.
The famous saying, when you the battle plan changes the moment you meet the enemy, right? So,
run away.
Yeah, it's you're gonna build it and then you're gonna ask a customer to use it, and then you're gonna find out you have a lot more stuff that you need to do. Or like every project eventually kind of has those moments, but if you have a good team, you'll get through it.
Yeah, and a lot of these things, just in general, for especially hardware startups, but also like larger companies that are developing a product that they've never developed before, like getting some experts on early on to kind of point people in the right direction is super important. And I think even in the larger companies that gets delayed way too long, because you got like the engineers who are like, okay, I'm smart, I can figure this out, and it's like it's totally outside of their realm of experience. And they probably could after many years, right? But to get them to produce something that works the most efficient way it could be designed in a super short timeline, like that's crazy. Just spend the money on someone who can help you. And I think the other thing that I see, just like really in general with companies developing new hardware for the first time, is the ones who fail don't know what to skimp on and what to splurge on. And like talk to like Kyle.
I mean, that goes back to kind of what I was saying about you should really try to only invent the parts that are the actual competitive advantage of your product, and you should really not invent anything else. I mean, that's like a surefire way to make your budget much, much larger, is to just kind of, we picked a microcontroller. Oh, okay. Technically that can do that, but it's going to take a long time, right? Whereas if you can, it's a safe bet. Like if you need Bluetooth, you should probably just go on to like SparkFun or Adafruit or Amazon and just look up like Bluetooth dev boards and like see what chip is on those, and like that's probably one you should use.
Great free tip from Kyle Visner. Oh my gosh, I'm having a brain fart. Oh, the other thing I was gonna say is, yeah, besides just the, like component selection and the actual choices you're making about your hardware, I
Mhm.
see founders and engineering leaders skimping on, not paying for the people, not paying for, like, as you said, like, like you saw that one project where one guy said, yeah, I could do all these things. And like
Mhm.
the tail end, the engineering work itself is also something that really shouldn't be skimped on. That's not where
Mhm.
you want to be saving your pennies. You want to like eat ramen for a little while. Don't
Yep.
upgrade your iPhone to the latest version, but don't
Yep.
go with the cheapest engineer you can find.
Yeah. Yeah. That's yeah.
Okay, great. Glad you agree.
I full agreement.
um, So you aren't really just completely on your own, though. You've told me that you sometimes will work collaboratively with other people as needed for
Mhm.
certain projects. What kind of
Yep.
other disciplines might you reach out to in your network?
I mean, the key four typically are, well, including firmware, which we, so the key other three would be electrical, mechanical, and industrial design. Um, Mainly because I'm just in a lot of, like, I tend to do a lot of kind of like consumer products, and it's like they have to, work electrically. They have to work from the software side. They also need to hold up to, people dropping them and all that, and they need to look good.
Yeah.
So that's those four. Um, then, but I mean, then you start getting into more complicated projects. So like I've worked with on a couple projects where, like, I would say I reach out to someone who I really classify as like an electromechanical engineer,
Mm-hmm.
which is not neither an electrical or mechanical engineer. They're like the best thing I can describe it is like animatronics, but they're not making like robots for Disney, but like large scale electrical stuff, right? So they're not going to design printed circuit boards, and they're not going to like design end use like mechanical devices, but they can build out like large scale wire harnesses running to like
Oh,
organizing and planning like how the components talk to and work together on like a macroscopic level. So like, you know, terminal blocks here, and they're going to route here so that they don't get pinched and short. And like, we're going to put a certain kind of motor driver over here. And like, these are like big components that like, it's
wow.
not like pure electrical engineering.
Mm-hmm.
I don't exactly know the discipline to call that. You can call it a couple different things, but industrial engineering maybe sometimes. I don't know. But that's relatively common because
Hmm.
a lot of people think of IoT devices as wearables, but they can be, trucks.
Yeah.
So, and it's kind of a different discipline when we're talking about low power embedded electronics versus, high voltage, high current systems. So there's that, and then there's, you start getting more into the niche stuff like medical, like some sort of advisor to do all of the help advise the FDA process and the regulatory regime there. Um, Optics, if I'm doing something, with optics, which I've done a couple times.
Thanks, Kyle.
And yeah, yeah, I mean, the space is huge. um, and so it's just really, it can be really project dependent.
But a lot of the companies you work with also have their own teams too, right? Or
Yes.
no?
Um, yes and no. They might have their own teams, but they oftentimes won't have. If they're engaging with someone like me, it means like someone like Facebook and I'm
Yeah.
just going to use an example because I know they're doing a bunch of hardware development around right now, right?
Uh-huh.
They're not really engaging with outside engineering firms. Like they're just hiring lots of engineers and like building it all inside. So yeah, I mean, I'd say if they're engaging with me, they probably don't have many engineering resources in house. So typically we're talking more like SMBs that are
What does
developing
that
projects.
mean?
Small and medium-sized businesses.
Oh, right. Okay.
As opposed to potentially like, large scale firms that have their own engineering departments. They typically will try to bring in their resources in house.
Yeah. Well, that's good that you have a good network that you've built up through
Thank you.
networking, which I tell everybody to do, which is how I've met you in Seattle at the the Seattle New Tech events.
Yeah. Was it New Tech? Yeah, maybe.
Yeah.
One of them.
Are there other ones? What are the other ones out there? Did I miss them while I was
post-COVID world? I'm not sure yet. We'll find
out.
out.
Good point.
Yeah.
Yeah. So
Right.
people can find you
Mm-hmm.
if they're interested in trying to hire you, even though you're super busy. At Spinnaker.Design, right? Can they just shoot you an email if they're interested and like a longer contract with you?
Yeah. Well, they can reach out through Odd Engineer, and then they can also, there's my website, Spinnaker.Design, and my email is Kyle@Spinnaker.Design.
We got all your deets now. It's all public. Anything
or
else?
message me on LinkedIn.
Yeah. Okay. Good to know. Anything else you want people to know? Anything else? No,
I think so.
covered all the things. Awesome.
I think so.
Great.
All right.
Thank you so much for your time, Kyle. I appreciate it.
Well, thank you. It was a pleasure.